In the field of molecular modeling, you often find strange units, especially for energy. For example, popular parameterization of the Lennard-Jones potential for argon, that is two quantities. Epsilon is the energy minimum, and sigma is the size of the atom. These can be written in different forms. You would expect that energy simply should be given in joules, and sigma in some length units. You will probably not hesitate how to convert these, but as regards epsilon, it's not so easy. For example, I wrote here that this is the same or equivalent to some amount in joules per mole. So let's try to convert this. I cannot write this equals something that has a different unit. So I wrote here this symbol, meaning that it is interpreted is or is equivalent as this in joules per mole, and I know how many molecules is a mole. So another interpretation is it is per one molecule. So to convert, I divide by the Avogadro number, and by this division, these per mole units cancel out, and what I get is the result in standard SI energy units. Also, often instead of joules in any context, you can use calories. Usually we used the so-called thermochemical calorie. Here there are different types of calories, but in this field this type of calorie is used, and to convert this value to calories is easy. Just multiply by the conversion factor here. Here there is a small difference because of rounding. Don't worry about this. Here I can write the equal sign because it really is equal. It's just the same quantity in a different unit. But what about the temperature here? It's interpreted in such a way that I need a conversion factor between energy units and temperature. And this is the Boltzmann constant by definition. Of course, to write this is lazy. In fact, one should write that epsilon divided by the Boltzmann constant equals this value. But to convert, I simply multiply by the Boltzmann constant. Again, mention here that these units cancel out, and that's the trick. By the multiplication, I get again the energy. But also I can merge these two tricks. I have the so-called energy in Kelvin, and if I multiply it by the universal gas constant, I'll get the value in joules per mole. That is not per one molecule, but per the Avogadro number of molecules, that is 1 mole. Again, just check these units here, that I'll get really the same. And the last unit, which is sometimes used, usually not in this context, but sometimes, is the electron volt. The electron volt is defined as the energy that one elementary charge gets where it goes through a potential difference of 1 volt. 1 coulomb times 1 volt is 1 joule. So by multiplication of the charge of an electron, which you remember, or better said elementary charge, I get the conversion factor. So once again, just by multiplication this by the conversion factor, again here I can write that it equals, I get the energy. Here you can mention the newest exact values of these two constants, it means that now the Avogadro number is defined. That is, 1 mole is defined by this number. The Boltzmann constant is defined in this way. Actually, this means, because the energy unit is considered the basis, that 1 degree, 1 Kelvin is defined by this value.